Hello dear students, today we are going to learn about heat and their related concept. In this chapter we have to learn about what are the different states or transformation of states of the object, that is solid, liquid and gases. Then the specific latent heat, anomalous behavior of water, resiliation, then specific heat and their units, and heat exchange principles. These concepts you have to study in this chapter. You already know that there are three states of the objects or substance, that is solid, liquid and gases. These states we can convert from one state to another. Means we can convert solids into liquid, or liquid into gas, or gas into liquid, or vice versa, liquid into solid. How it is possible? It's possible by increasing the energy or giving the extra energy to solid. It will melt and it transfer into liquid. If you supply the energy to liquid, it will convert into gas, like that. If you cool the gas, that will become in liquid state, and if you cool the liquid, it will become solid state. First we will see what is melting point and what is boiling point. Already I have said that the solid state of the substance can convert it into liquid state. That means we should melt it. At this process of melting, the temperature is constant. This constant temperature at which the solid converts into liquid state, that temperature is known as melting point. What is melting point? A constant temperature at which we are converting that solid state into liquid state. That is known as melting point. Then what is boiling point? A constant temperature at which the liquid is converted into gaseous state. Liquid is converted into gaseous state, and in this process the temperature is constant, and that constant temperature at which the liquid converts into gases, that is known as boiling point. Then what is latent heat of fusion or latent heat of vaporization? Specific latent heat of fusion, the amount of heat energy absorbed at constant temperature. Amount of heat energy absorbed at constant temperature by unit mass of a solid to convert into liquid phase is called a specific latent heat of fusion. The amount of heat energy absorbed at constant temperature by unit mass of a solid to convert into liquid phase is called specific heat of fusion, specific latent heat of fusion. During transition of solid phase to liquid, the object absorbs heat energy. While transforming the solid into liquid, that object absorbs heat energy, but its temperature does not increase. This heat energy is utilized for weakening the bonds between the atoms or molecules in the solid and transform that object into another phase, means in liquid phase, solid to liquid phase. The heat energy absorbed at constant temperature during transformation of the solid into liquid is called the latent heat of fusion. Then, what is specific latent heat of vaporization or latent heat of vaporization? In this case, the amount of heat energy is absorbed at constant temperature by unit mass of a liquid to convert into vapor stage or gaseous stage. Gaseous phase is called specific latent heat of vaporization. Amount of heat energy is absorbed. Amount of heat energy is absorbed during this process of converging liquid into gaseous state. At that time, a constant temperature is there. That's why the amount of heat energy absorbed at constant temperature by unit mass of a liquid to convert into gaseous phase is called a specific latent heat of vaporization. In this process, during transformation of liquid phase to gaseous phase, heat energy is absorbed by the liquid, but its temperature does not change. The constant temperature at which the liquid transforms into gaseous state is called a boiling point of the liquid, and the heat energy absorbed at constant temperature during transformation of this liquid into gas is called a latent heat of vaporization. The heat energy absorbed at constant temperature during the transformation of liquid into gaseous stage, that heat is latent heat of vaporization. Then we will see about resiliation. For this purpose, we can do one experiment. If you take an ice slab, we are taking here a ice slab, and which is kept on a table or support, like this two supports you have to keep here, and on that is a ice slab. This slab of ice we have to keep on stand, as we shown like this. Hang two equal weight to the two ends of the metal wire. This is a metal wire, you have to keep like this. From this side we can, and we have to hang or to attach two equal weights on two ends of the metal wire, and this wire we are putting on slab as shown in this figure. What do you observe here? This metal wire gradually penetrates the ice slab. Gradually this metal wire will penetrate like this in this glass slab, in this ice slab. So like this wire will penetrate, goes on penetrating in the ice slab, and finally it comes at lower surface of that ice slab. But if the wire penetrates through all over this ice slab, passes through this ice slab, but there is no breaking of this ice. We can't see the breaking like this behind the penetrating wire. Why it is so? Because after passing the wire through this region, the melted ice will reconverts to ice once the pressure is removed of that wire. And this phenomenon in which the ice converts to the liquid due to applied force. First, here the ice converts into liquid because of pressure of that wire, but after passing the wire, that liquid is again reconvert into ice because there is no pressure, and this reconversion and rejoining of the ice slab because of removal of pressure on it, that is known as resiliation. What is resiliation? The phenomenon in which the ice converts to liquid due to applied pressure and then reconvert ice by removing the pressure, that is known as resiliation. In this case, the melting point of the ice becomes lower than 0 degrees Celsius due to pressure. This means at 0 degrees Celsius, the ice gets converted into water. As soon as the pressure is removed, the melting point is restored at 0 degrees Celsius and water gets converted into ice again. But under pressure, we can decrease that melting point of the ice. A reconversion of ice water to liquid. First, here is the conversion of solid to liquid because of pressure, but after that, after removing that pressure of wire, that liquid is reconverted into ice. This process is known as resiliation. Then we'll see about anomalous behavior of water. What is anomalous behavior of water? In general, when liquid is heated up to a certain temperature, it expands, and when it cool, it contracts. Generally, in case of liquid, when liquid is heated up to a certain temperature, it gets expand, and when we cool it, when we are cooling, it gets contracts. This is in general. But in case of water, water shows a special and exceptional behavior. What is that? That if we heated the water from 0 degrees Celsius to up to 4 degrees Celsius, it contracts instead of expanding. In general, liquids are expanding by heating and gets contracting by cooling. But in case of water, water shows a special and exceptional behavior. That is, if water heated from 0 degrees Celsius to 4 degrees Celsius, from 0 degrees Celsius to 4 degrees Celsius, if you heat it, does not get expand, it is contracts. It contracts instead of expanding, and after this 4 degrees Celsius it gets expand. But in this range, water shows exceptional characteristics or exceptional behavior, special behavior. This behavior is known as anomalous behavior of water. What is anomalous behavior of water? If you heat water from 0 degrees Celsius to 4 degrees Celsius, it contracts instead of expanding. And because of that, at 4 degrees Celsius, its volume is minimum. Means high density of water is at 4 degrees Celsius due to contraction, highest contraction. If the water is heated further, then after that it gets expanded and its volume also increases. This behavior of water between the temperature from 0 degrees Celsius to 4 degrees Celsius is called anomalous behavior of water. Because of this anomalous behavior of water, there are many examples which are related to this anomalous behavior of water. That is, in region with cold climate, the aquatic plants and animals can survive because of this anomalous behavior of water. In that case, in cold regions, these are the surface of, suppose this is the surface, upper surface of the lake water. Because of cold climate, it gets cool and is a formation of slab of ice. But here 4 degrees Celsius is temperature is maintained, and in that 4 degrees Celsius temperature, the aquatic plants, animals can survive. And this happens because of anomalous behavior of water. Also in cold region, in winter season, the pipes of water supply breaks because of anomalous behavior. Also there is a breaking of rocks because of anomalous behavior. So these are some examples related to anomalous behavior of water. To show this anomalous behavior of water, scientist Hope has made an apparatus, that is Hope apparatus. With the help of this Hope apparatus, we can understand how the anomalous behavior of water. In this, when there is, this is cylindrical bowl, and here is flat bowl. A flat bowl is attached to a cylindrical container. This is cylindrical container which contain water, water of general temperature, and this bowl, flat bowl, is contain mixture. It's cooling mixture, freezing mixture. There's salt and ice. And here there are two thermometers are there to measure the temperature. If we keep the water of general temperature, that is around about 25 degrees Celsius, in this cylindrical container, and we put the freezing mixture, that is salt plus ice, in this flat bowl, because of contact of this freezing mixture, water gets cool, goes on cooling, which is in cylindrical container, and by cooling that goes on contracting. But this process is up to 4 degrees Celsius, goes on contracting. Highest contraction is at 4 degrees Celsius. Because of this contraction, the density goes on increasing, and by increasing that density, this water comes here, and it is heavy water comes here, and water which is present here goes here. This is going on till the temperature of this area is up to 4 degrees Celsius, and that temperature we can observe on this thermometer. After cooling of that water below 4 degrees Celsius, current goes contracting. Instead of contracting, it goes on that expanding, and because of that, here temperature of this water we can see 4 degrees Celsius. 4 degrees Celsius, at 4 degrees Celsius, the highest density of water is here. Because of that, here total water which is present is of 4 degrees Celsius because of highest density. And now, because of higher density water is present here, the water which is at upper level of this container, cylindrical container, goes on now cooling, and same process is happening here. But this process is going on till there is a 0 degrees Celsius of water, and because of 0 degrees Celsius, this water gets converted into ice. So in this apparatus, like a lake, there is a ice slab on upper side and 4 degrees Celsius water in lower side, like that. This water will be at 4 degrees Celsius in liquid state, and here we will get that water is converted into ice, and temperature of that ice is 0 degrees Celsius. That ice is floating on that water, because we should always remember that the density of water is higher at 4 degrees Celsius, but in other liquid the density of liquid that at high density is at 0 degrees Celsius. But in case of water, higher density is at 4 degrees Celsius, and that's why ice is floating on that water. So with the help of this Hope's apparatus, we can study the anomalous behavior of the water. Then we'll see about next, dew point or humidity. What is humidity? Dew point and humidity. Humidity, the moisture in the air or atmosphere, is called humidity. Moisture in the atmosphere is humidity. About 71% of surface of the earth is covered by water, and due to this constant evaporation of water, water vapor is always present in the atmosphere. The amount of water vapor in the atmosphere has to understand the state of the daily weather. This presence of water vapor in the air makes the air moist. The vapor contained in the air is measured using physical quantity that is called as absolute humidity. How much vapor content is there in air? How much vapor content in the air is measured using a physical quantity that is known as absolute humidity. That is, mass of vapor present in unit volume of air is called absolute humidity. Actual mass of vapor present in a unit volume of the air. Mass of vapor present in unit volume of the air is called absolute humidity. Generally, absolute humidity is measured in kilogram per meter cube. Suppose unsaturated air at a certain temperature is taken. Unsaturated air at a certain temperature is taken, and its temperature is decreased. The temperature reaches at which the air becomes saturated with vapor. This temperature is known as dew point. What is dew point? Suppose we consider unsaturated air at a certain temperature. Suppose there is a 30 degrees Celsius temperature, and for that temperature that air is unsaturated. But in this case, if you decrease the temperature of that air, the temperature is reached at which the air becomes saturated. with that vapor, and this temperature at which air gets saturated with that vapor, that is known as dew temperature or dew point. Dew point temperature. A temperature at which that air becomes saturated with that vapor, that temperature is known as dew point temperature. Then a relative humidity. What is relative humidity? Relative humidity is the ratio of actual mass of water vapor content in the air in a given volume, actual mass of the water vapor content in air in given volume divided by mass of the water vapor needed to make the air saturated in that volume. Like this, we have to calculate the percentage of the relative humidity. The ratio of actual mass of vapor content in the air for a given volume and temperature to that required to make the air saturated with water vapor at that temperature is called the relative humidity. Means, first, how much vapor contents is there in given volume, and then we have to observe how much water vapor is required to saturate that air at that given volume. If we taken the ratio of these two things, we will get actual relative humidity of that air. If the relative humidity at dew point means there is a 100% humidity should be there. At dew point, relative humidity is 100%. And if the relative humidity is more than 60%, we feel that the air is humid. And if the relative humidity is less than 60%, then we feel that air is dry. When relative humidity is 100%, the temperature is dew point temperature. When the relative humidity is more than 60%, then that air is humid. If the relative humidity is less than 60%, then that air is dry. So we can classify this dry air, humid and dew point on the basis of how much percentage of relative humidity is there in the air. Then unit of heat. We already know that the SI unit of heat is joule and CGS unit of heat is calorie. What is the relation between calorie and joule? SI unit of heat is joule and CGS unit of heat is calorie. What is the relation between calorie and joule? 1 calorie equal to 4.18 joule. This is the relation between calorie and joule. We are going to see about what is calorie, 1 calorie, and what is 1 kilocalorie. 1 calorie means the amount of heat necessary to raise the temperature of 1 gram of water, the amount of heat necessary to raise or increase the temperature of 1 gram of water by 1 degree Celsius from range 14.5 degrees Celsius to 15.5 degrees Celsius. This is called as 1 calorie heat. You have to take always the range of this increasing temperature, that 14.5 degrees Celsius to 15.5 degrees Celsius, means there is an increase in 1 degree Celsius. Why we are taking this range? Because that calculation of that increasing the temperature we can get correct in this range. That's why you have to take this range, 14.5 degrees Celsius to 15.5 degrees Celsius, means 1 degree Celsius of increase in temperature will get here. So we have to define this 1 calorie like this: the amount of heat necessary to raise temperature of 1 gram of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called 1 calorie heat. Similar, we have to define this 1 kilocalorie. Here, the amount of heat necessary to raise the temperature of 1 kilogram of water, 1 kilogram of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called 1 kilocalorie heat. So this is the 1 calorie heat and 1 kilocalorie heat. Then we will see about specific heat and its unit. What is specific heat? The amount of heat energy required to raise the temperature of a unit mass of an object, any object, by 1 degree Celsius is called specific heat of that object. Amount of heat energy is required to raise the temperature of any object, unit mass of any object, by 1 degree Celsius is called specific heat of that object. The specific heat capacity of the different object is different. If you see, if you observe experiment of this, in which there is a we can observe the different absorbing capacity of the object, heat absorbing capacity of the object. For that purpose, if you take an iron, copper sphere and lead sphere of same amount of mass, to study the specific heat capacity, we can do the experiment, and with the help of this experiment we can imagine how the different specific heat capacity of the different object. For that purpose, we have taken here 3 spheres. One sphere is of this and above iron. Next is copper sphere and lead sphere. All spheres are of same mass. Suppose it is 1 kg, 1 kg, 1 kg. These spheres we have to keep. First we have to keep in boiling water. Those spheres will heat it by absorbing the heat from the boiled water. And then those that 3 spheres you have to pull and keep on this slab, wax slab. What we will see that that spheres are go deepest and some are the depth taken or depths of that melted wax is low. Here you will see this sphere goes here more deepest. This sphere will go low depth, and here this will go intermediate depth. Here we can observe that the iron sphere goes deepest into the wax. Lead sphere goes lowest, and copper sphere goes intermediate depth. This shows that for equal rise in temperature, the 3 spheres have absorbed different amount of heat. We already kept this first in same boiled water, but they absorb different amount of heat, and because of there is a different amount of heat absorbed by them, they emit or they loses here that heat also different. This loss higher heat because of that iron sphere goes at high depth, and compared to this the lead sphere penetrate here somewhat less because he lost low energy.